All right, so we got the classic birch reduction. What a fantastic reaction. So this is just gonna be pretty simple overview. So the way you're gonna see this is just the the most simple case here. So you got sodium, you got Na. I think it might be sodium. I don't really remember. Anyway, Na, metal. That zero thing means metal. And then NH3, which is ammonia, liquid version. What that does is it just takes it down to this or this, same thing. All right. And then just on the other side, this is just something else. But anyway, yeah, you can do that. So watch out for that. But that's not birch reduction. Going back to the B reduction. So you've got like a group on here. You could also do Li or NH3 in liquid. These are the only two you're gonna see. You're only gonna see this one or this one. I'm pretty sure. All right. So the group can either be away from the double bond or, and again, these two do the same thing. The Li or the Na, doesn't matter. Same thing. So it's just a different thing, but same reaction occurs, the birch reduction. So you're either going to get this or this. Now it's like, okay, which one are we going to get? So the way it works is this. If you've got, so we already know this. We've done a lot of good stuff. Now we know this is an electron withdrawing group. When you do the birch reduction with an electron withdrawing group on the benzene ring, then it goes away from the double bond. That's how I remember it. Electron withdrawing goes away. That's just how I remember it. Electron withdrawing goes away from the double bond. So that's how that works. Electron withdrawing group. The electron withdrawing groups for the birch reduction are going to be these groups. Let's show you. So you got the ketone. Obviously, I just showed you that. We could have a nitro group. We could have a nitrile. All right. Moving on to electron donating groups. A lot of people get confused here. This has lone pairs. We've figured this out already based on we've done the directing effects, so you guys know this is a electron donating group. It's got lone pairs. Anything with lone pairs is an electron donating group. So what you have to remember is that, or what I like to remember is electron donating, it goes on the double bond. That's one way you can remember it, with like just the way it sounds. Electron donating goes on the double bond. So in this case, that'd be your product, because it's like this part's on it's connected to the double bond. The thing that is there is on the double bond. So this would be a valid structure too, because it's on the double bond. You see how it's like really actually on it, as opposed to that position, which is away. That's away from the double bond. So here, yeah, with the electron withdrawing, that's away from the double bond, because it's not touching it, it's away from it. Electron withdrawing away. Electron donating, lone pairs, those lone pairs there, it goes on the double bond. It doesn't get much simpler than that, just remember that. Electron donating groups are groups such as alkyl groups. So there's like an ethyl group, it's an alkyl group. We already showed you ethers right there. And then we've also got maybe you got the NH2, because the N has lone pairs. Or say there's a methyl groups coming off there, that works too. Or that works. Okay? Electron, it's got lone pairs, so it's on the double bond when you go to do this thing. It's pretty simple. Just remember that, and just use the tricks that I showed you with the words, and you should be good to go.